I said, I'm Sanji. I'm the Director of Marketing here, and we are joined today by Andrew Anderson, who is the VP of Innovation and Informatics Strategy here at ACDLabs. He has been working with many groups over the years on analytical data management, on digitalization of workflows. And so it's my pleasure to introduce him. And Andrew, handing things over to you.
Hi, everyone. Thank you for making time today. Thank you to Sanji for the introduction. Today, I'll be covering the digitalization of analytical workflows and perhaps some strategies for success. In terms of a presentation outline, sorry, I'm having some difficulty here. There we go. Okay, so utilization of analytical today, some scientific and data science use cases. We see a common theme in the modern labs of having access for scientists and access for data science for model building and prediction alike, but we'll get into it. What are some of the challenges with how to better utilize analytical data? Balancing long-term strategy with today's goals, right? Everyone has a long-term strategy, but how do we glean value out of the data we're acquiring today? And then finally, some strategies for successful digitalization of analytical data. When do you start? When's the right time to start? And what sort of cloud considerations are important for these successes? This is a bit of a play on Maslow's hierarchy of needs, but the digital hierarchy when it comes to organizations that want to use analytical data. Indeed, a lot of folks want to incorporate analytical data into their machine-augmented decision support interfaces and the like, a so-called self-learning organization at the aspirational part of the hierarchy. But you can't get there without addressing your most basic needs along with integrity and security considerations. In the end, scientists being more productive, being able to do more science and less, call it data engineering efforts is an important consideration in the hierarchy. So some benefits certainly for doing this kind of work. So, it's important that in a scientifically driven organization that data flows through it and you provide facile access to help with making decisions, to perform better experiments over time. And in the end, having democratized data to make it effectively accessible is one of the important benefits of implementing a digital paradigm. What I also like to think about is context for data. And so considering that you have these increasingly disparate set of potential users, influencers, and beneficiaries when it comes to analytical data, what's the typical data generation and data flow in an R&D organization? So scientists conduct experiments that produce samples which are then subjected to some sort of analysis. From that acquisition of characterization data, for example, results are used to make decisions. Those activities are supported by a variety of systems. ELNs are traditionally used to document experiments. LIMS facilitates the request of certain types of analysis from the experiments documented in the ELN. Instruments are leveraged to acquire data. And then a series of expert applications are used to perform processing, analysis, and reporting of that data. From an associative perspective, in your ELN, you'll have project ID, experiment IDs. In your LIMS, you'll have sample IDs, presumably instrument and method identifiers that produce data, and all of that needs to be related so that you can trace back to looking at the experiments you performed and the characterization data you've acquired. During that journey, you're producing data, raw data, straight off of the instrument detector channels, the results of the processing of that data, peak detection, integration, et cetera, and then interpretation, right? Assigning, for example, peaks to certain identities in a mixture, for example. But in addition to that, the emergence of utilizing data by data scientists. So the need to pipeline data, leverage those IDs from different systems to pull in method information, sample and experiment information in a related fashion. Instrument data then needs to be placed in some sort of repository so that it can be used in, for example, predictive modeling. And then once data is pipelined to the appropriate place, data scientists perform analytics, hopefully facilitating the creation of that self-learning system we talked about in the hierarchy. And so what are the capabilities needed to support these types of workflows? Well, you need the ability to view, process, and analyze analytical data on demand. And the point where you as a data scientist or a scientist need access to that data, how do you get access to it? Of course, then the ability to automate some of the data flow, right? Detection of data from the presence, move it to the appropriate analysis system, perform integrations. We'll talk a little bit about data assemblies in a little while, but then also being able to abstract information from that potentially very large set of raw data coming off of instruments. So the ability to store, normalize, and structure data in an appropriate way such that machines can consume the output from your various places. So there are challenges in this area. So what's some of the typical challenges? As we all know, as I'm a former analytical chemist, each of your experiment types require a unique combination of equipment, right? LC-MS versus NMR is a classic example. There are different supporting software systems and correspondingly different data formats. ACDLabs is well known to support the broad variety of formats in our platforms. The impact of such a challenge is that there must be the capability to assemble digital representations of those characterizations experiments when often you have different analytical means to characterize a certain substance. Right now, you're relegated to scientists curating those data sets by hand, putting them into static reports, and there are consequences of that sort of manual data curation. It requires scientists to do data engineering, and as such, having less time for experimentation. So as an example, a summary of those human data association challenges, you have to associate samples with experiments that you've performed. There's a variety of data files produced by the instruments that you have access to. You have to process with different types of software interfaces. So you have to become experienced and have training on those various software applications in regulated workflows. The training records for that effort is inactive and needs to be updated quite frequently. So maintaining that knowledge can be a challenge if you have a lot of different systems to use in your experiments. Of course, then for data integrity purposes, associating reports and the like to that experiment info, and the data assembly step is often necessary and a burden. Just as an example, the heterogeneity challenge, I think, is well represented. This is a specification in the pharmaceutical industry. Think of this as like a drug substance specification, a relatively simple one. Identity, impurity profile, elemental analysis, residual solvent, water content, and residue on addition, just as a snapshot of the types of specifications that substances must adhere to. Those are all different analysis techniques depending on what lab you're working in or what set of labs you're working in. You may have a different distribution of analytical systems. They're the same technique, but different, let's say, instrument vendor. And as such, the data formats can be quite a large variety, as an example. So some of the challenges of analytical data as it pertains to utilization in a digital paradigm. Data exists in silos. Some of the experimental context can be missing. I've seen a lot of implementations of data management systems over my career, and oftentimes the experimental context that depicts the data sitting in a file system can often be missing, and there's some other effort that needs to be conducted to establish that context, ELN numbers and the like. The data often we see, once it's abstracted, if you needed to reprocess the data, you have to go back to that siloed originating system, which can be a challenge if you're working in a highly distributed organization. Data is often frozen, implying that you cannot reprocess it. And certainly in a lot of cases, it's not digitalized. If you consider, for example, a certificate of analysis, certainly allows for a human to interpret quality results and make decisions. But if you want to do any sort of comparative analysis, it's really difficult to compare, let's say, HPLC profiles depicted in PDFs. You know, it's difficult to arrange a stacked plot as something as simple as that. Furthermore, the challenge of analytical data assembly is an important one. This horseshoe loop depicts a typical dereplication experiment or analysis that is done in a lot of organizations if you deal with mixtures of any sort. So if you've profiled your sample via chromatography, first step you want to perform is looking at the identity of certain components, so that as you acquire more information about a mixture, having the ability to know what a particular peak represents in terms of its identity requires the acquisition of more data. So, for example, collecting LCMS information over time to get structural fragments. You may collect multiple LCMS experiments. Ultimately, if you isolate samples from your mixture, collect NMR data, you may arrive at structure-based identity of those components. Where it gets tricky is that data assembly cycle repeats for every chemical entity you observe, and you can imagine the volume of mixtures you may characterize. When it comes to the different techniques utilized in this cycle, there's no single representative data file. It's a collection of data files. So being able to support data assembly at this level is typically what is important for complete identity characterization. So I'll skip this slide. In the end, analytical data needs to be digitalized, standardized, so it can be related to same technique, but maybe different instrument vendor or format, centralized and integrated into your IT environment. We'll talk a little bit later about IT considerations for digital strategies, and live. I look at a lot, as a former analytical chemist, we saw that between 20 to 50% of the data that you acquire can often need to be reprocessed for certain applications. If your automated processing missed certain attributes of the data and requires a reprocess event, how can you perform that reprocessing without access to the originating data? And if you've abstracted that data, it's often difficult to reprocess to obtain new answers on previously acquired data set. And finally, and probably most importantly, is that data needs to be contextualized, and we'll talk a little bit about that later. So as an example, here's some live data, right, where if I've performed peak detection, provided a nominal identity, right, meaning this is a peak with this relative retention time, being able to, for a component of interest, assemble related data acquired by different instrumentation can often be an important capability requirement for digitalization. So just as an example, proton NMR, carbon NMR, two-dimensional experiments. Moreover, being able to associate molecular structures, candidate structures to identities over time, and as you acquire more information, being able to update structures in that data file can often be important. So just as an example, here's the ability to associate associate a structure for the purpose of confirmation. and assuring that the data you have is consistent with the assigned structure. So with all of these considerations in mind, what are some of the successful ways to digitalize analytical data? So as you know, that we've heard from customers that there are standards that folks aspire to, different organizations aspire to set standards for analytical data. Our position on when is the right time to start this process is technology adoption never ends, okay? And what I mean by that is as technology in different disciplines and areas evolve over time, if you're waiting on the perfect time when evolution of certain technologies is complete, it won't be complete. And so as a consequence, sometimes it's better to start at perhaps the proof of concept level and implement something to realize value sooner than later and not wait on a perfect set of standards to be implemented. The good news is that when it comes to analytical data, data can be standardized. Those techniques and formats can be standardized currently on the Spectrus platform. And what that then allows is for, as standards emerge or become ratified, you can convert that data to future formats when the standards are made available. Another thing that is important is to consider your data normalization efforts. When it comes explicitly to sample metadata, the metadata associated to your analytical results, describing your sample information, your experiment information, and your analysis method. Currently, though the formats of that metadata can be different depending on what vendor data format you're managing today. And so if you want to implement another vendor format, vendor instrument, and corresponding format, I've observed that sometimes the instrument or vendor specific way that this metadata is managed needs to be updated. And so when you embark on this journey, it's especially important to consider the data normalization efforts pertaining to sample, experiment, and analysis method. When it comes to getting started, I always like to say set achievable goals, right? Start by defining your metadata strategy as previously defined. Establish a set of controlled vocabularies, particularly for things like peak naming, right? As an example, peak retention time or attributes of peaks observed in chromatography are method specific. So in addition to call it behavior attributes like retention time, make sure to include like method information in the peak name, because if the method changes, obviously your retention time will likely change as well. And so being able to establish the method to behavior traceability is often important. It's also important that a lot of times when you implement such strategies like controlled vocabularies and metadata, ensuring that the business processes that you and your scientists follow, there will be change. And so managing the impact of those changes is really important. Moreover, a point of emphasis is around reducing this human effort to digitalize. And so having a well thought out automation and integration strategy between your originating systems, as we talked about before, LIMS and ELN, for example, how do you automate not just data flow, but associative data from different systems, ensuring a well characterized digital data set is an important aspect of the strategy. I also say, start with digitalizing your most impactful analytical workflows and strike an effective balance between impact, effort, and value. I don't recommend boiling the ocean and trying to take your exhaustive set of instrumental methods of analysis and not starting on a digital journey until you have an effective plan for all of your different techniques. If you have infrequently used instrumental techniques and would need to wait on that technique to be supported by some standard, better to hold it for future phases and implement what you can do today in terms of digital. I also like to say define success in stages. You want to complete an implementation for an initially well-defined workflow, something that you can handle from an integration, metadata, and technique perspective. Then extend those initial implementations to so-called adjacent workflows. May have a different set of data types, but perhaps it's a format that you can support, a set of metadata access points you can pull. That would be the next step in an implementation. And then for more difficult workflows, I recommend allocating a define and design set of resources. So for those of you in the audience, I haven't seen Sanji's poll results yet, but for those of you that are in business analyst roles, being able to allocate resources to define and design steps. So you lay out a plan for those more difficult workflows. And of course, you can work with partners, vendors like ACDLabs, for example, to support the implementation of those more difficult workflows. Certainly. For reference, the recommendations that we're talking about today are a well-traveled road. Some resources that you might want to take a look at is Pfizer has partnered with ACDLabs to implement these such digital capabilities within their organization, supporting those types of implementations. There's a strategy brief that describes more of what I'm talking about today in a lot more detail. And then there's a white paper talking about analytical data standardization in particular. So who should be involved in analytical data digitalization projects? So what we've seen is that successful projects are human-centric. So make sure to involve all stakeholders, right? The emergence of data science in R&D organizations is an important change to the R&D paradigm across industries. So making sure that data scientists, IT, and scientists performing experiments, collecting characterization results, managing samples in and out of labs, all call them stakeholders, should be considered as part of that journey. Another important consideration is the cloud. And from my experience, most organizations are considering further adoption of cloud-based resources. When it comes to the cloud, certainly ACDLabs has experience implementing cloud-based analytical data management solutions, as evidenced by our work with Pfizer and others. But one really important consideration for me, both in my current role and as a former scientist, is it's really important to consider when and where will data need to be accessed. As an example, if you are collecting data where you need to make a decision as soon as acquisition is complete, you don't want to necessarily wait on the routing of that data to a final destination or repository. If you're relying on moving data to the cloud to access it, it may be important to consider a so-called staging environment. We would use the term an edge computing environment that's not yet on the cloud, but close to your data source analytical instrument. And so having that very close connection to make data accessible. And you can still automate the extraction, transformation, and loading of those data sets onto a so-called edge or staging server to make it immediately available. But you don't want to necessarily wait for certain data types to get to the cloud. It's also important to know, like, build an effective migration plan when you consider the cloud, when data needs to be made available to all stakeholders. So some other ADMS considerations. What are the ideal set of access interfaces? Certainly software applications that allow you to pull up data in an interface like Spectrus processor or one of our newer products, Spectrus JS. What are the marshalling services? From my days and many years ago, the marshalling services were humans accessing data via the network. but is there more effective and more valuable ways to move data from the originating location to accessible destinations? What are your collection of monitoring and marshaling services? We spend a lot of time dealing with those marshaling services and can provide some insight into how best practices can be implemented. In addition to marshaling and access, storage and management services. How will you maintain a effective and comprehensive representation of the data that you acquire, but at the same time managing that data in an efficient, cost-effective way? What is your business rules for hot storage versus so-called cold storage and archival practices? So important considerations. Like we talked about briefly, the dynamic nature of some types of analytical data require processing, analysis, and interpretation resources. So how are those made available, those resources? In addition to the data access capabilities, being able to reprocess on demand is often an important consideration for implementing an analytical data management system. And then reporting and what I like to call proliferation of information. Certainly PDF reports and our capability to support Office document generation is important for human proliferation of results. But would it also be valuable to have web-based access to certain types of data for decision making? And then finally, ETL for ML. The ETL stands for extract, transform, and load data into machine learning applications. Being able to prepare that data for predictive modeling applications can be very important, but it's especially important for analytical data. And just as a pointer, we're having a second webinar getting into a lot more detail for these considerations. So I'd encourage you all to attend that webinar in the coming days and weeks. And so just as a representation of automated digital analytical workflows with the Spectrus platform, being able to take laboratory instrumentation as data sources, apply data standardization, associate experimental context to that set of data, being able to store and manage that data in an efficient interface, can be on the cloud or in these so-called edge computing environments, ensuring you have bidirectional integration between your other systems, right, for those metadata considerations, and also for promotion of results. Raw or processed or interpreted analytical data is one thing, but digital representations of results need to be proliferated into various subsystems. And those subsystems are represented in the schematic, but then also have the bidirectional access point to all of your stakeholders, being able to query data, reprocess as needed, update data sets with the appropriate credentials to do so are all important considerations. And just another example of how this works with the ACDLabs environment, data can be standardized, it can be integrated or assembled with providing output to third-party systems and a variety of client applications. If you're familiar with our Spectrus platform, we also have support for specific, call them analytical or scientific workflows with our Luminata and Catalyst applications, respectively. In terms of IT support, what are some of the important considerations for those of you that have IT responsibilities for such initiatives? Having the ability, as we've talked a little bit about, the different heterogeneous data file types, ensuring that you have a consistent plan across your different techniques may require data normalization as a very first step. As we talked a little bit about before, inconsistent data ontologies is a really important aspect of this. Ensuring that your experiment, sample, and method information, along with your process results, are stored in a normalized data ontology can be a really important consideration. So ensuring you've established a data ontology is certainly important. Scalability and support. if you calculate the number of experiments acquired, data sets acquired in a given year, right, and look to consider across your organization, the ability for your applications, your network, your databases to work at that scale can often be an important consideration for IT when you're assigning resources to particular requirements of the system. It's often important to load test and pressure test over time. What are then the data query and transfer rules that need to be established? Moving data between the data source, a transitionary data repository, and then of course a long-term storage system, and what are your appropriate rules? How do you query data across that distribution, etc. And then of course integrations. Integrations to both third-party applications, LIMS or ELN, or downstream business intelligence applications, not just for machine learning, but for scientific colleagues making decisions based on access to the data. What are the BI applications of interest, and how can we integrate to it? With the careful consideration of looking at the variety of different data sources available to these systems. So knowing that one lab may have a different distribution, same techniques, but different distribution of data sources across departments, between sites, and even between storage types, cloud versus lake versus relational database, for example. So just as a schematic, implementing an analytical data management system with that so-called machine learning infrastructure. So if at the top, these are your instrument data sources, right? You have an integration layer that performs the data marshaling step and the data integration step, providing metadata context, for example. You then have a collection of applications that access those. And then of course, once you've performed the normalization for machine learning, training set incorporation perspectives, how are you storing and managing those results, those transformed results at a so-called object store layer? And so for those of you that have IT responsibilities, I'm sure these are familiar ways to depict a system, but these are capabilities provided by ACDLabs to support such a system. In addition to the capability to present interfaces for scientists to interact with data, process, view, analyze, interpret, etc., being able to offer a data processing API for so-called data science applications is often important. And this is a bit of a representation of the capabilities in some of our backend, but I think it's important to say, hey, you have programmatic access to some of these processing functions, which can often be important for the data treatment steps necessary for machine learning applications. So I just wanted to highlight that these capabilities are available if you need that programmatic access to data processing functionality. So in summary, strategies for successful digitalization of analytical workflow. As we talked about, start now for the most impactful workflows that you have. Consider that analytical data normalization as an important step, ensuring that you involve the right stakeholders, which include scientists, IT stakeholders, and so-called data scientists. Keep accessibility in the focus for cloud-based deployments. Knowing when folks need access to data is an important consideration for your infrastructure. And then assess your gaps between your current systems and processes and that improved future state. That will help you recognize, why am I doing this? Right? Why are we implementing such systems? Knowing what the gaps are can help you realize what value you're bringing with these digitalization efforts. Okay. Thank you for your time and attention today. I'm happy to answer any questions or